Hi, in this video we'll talk about GFP-GAN. In simple words, this network will generate this image from this image. We call this task blind face restoration. This neural network will generate high quality faces from low quality faces. Let's talk about it in details. Firstly, we have this module, degradation removal module. This module will remove the noise inside this image and the blur. In other words, it will clean this image from all these things. But it will not make it high resolution image. This module, it is just U network. As you can see here, it is just U network. Here we will train this degradation removal module, or in other words, we will train this U network to remove all these things from this image, from this low resolution image. How can we do that? We have this restoration loss. Firstly, we will resize our target image. Here we have the high quality image actually, and we will use it as a target. We will resize it and we will make the shape of it like the shape of this image here, the input image. As you can see here, it is clear. It is very good image. Now we will compare the output image or the output feature map from this unit and this target image, and we will update the weights of this unit to make the difference between these two things smaller and smaller. Now we will do this thing again. We will resize our image again to make it something like this. It is something similar to the image here, to the size of the feature map here, and we will compute the difference between these two things, and we will try to reduce this difference. So we will update all the weights to reduce this difference, and we will do the same thing here. We will take this image, this feature map, and we will compare it with the target. Actually, we will resize our original image, our real image, again to make it something similar to the size of this feature map, and we will compute the difference between them, or we will compute the loss value. We will try to update the parameters of this unit to reduce the difference. So by doing this, we will make our U network able to learn how to make our image, our input image, clean. Now we have good image here, clean image. It might be something similar to this target here. Now we want to increase its resolution. We want to make it high resolution image like this thing here. How can we do that? We will use pre-trained GAN to create this high quality image. Here we will use, let's say, StyleGAN, which trained previously on large data set, and we can use it to create faces, high quality faces. Now the important question here, how can we make this pre-trained GAN create the same face in our input image, this noisy image, but with high quality like this, and of course without noise and blur? Now we will learn that. Firstly, we have many layers in this pre-trained GAN network. We will not train them, we will freeze them. So we will not update their weights because we need to use them because they trained previously on large data set and they know how to create high quality faces. So why we need to train them? But we need to guide these features that we will get from these layers inside pre-trained GAN network. How can we do that? Firstly, we will take two things from our degradation removal module. The first thing is F latent. What is this? It is just, let's say, a vector which has the most important thing in our input image, of course without noise and blur. Now what we will do actually, we will pass it through dense layers, linear layers. We need to do that to convert this feature vector. Let's say we have this feature vector which has the first feature, second feature, the third feature. Let's say we have just 3 features, but actually we have many features. So we will pass them through this dense layer. This dense layer has many trainable parameters. Weights has weights. We will train them to convert this feature vector to something suitable to pass it through this StyleGAN. So we will convert it into new feature vector. Here is the first feature, the second feature, like this. Let's say that our StyleGAN expects that the input to it should be a feature vector with 4 values, 4 features. So here we should make this multi-layer perceptron has 4 nodes. We will pass these 3 features and we will map them to this new features vector which has 4 features. And the values of these features will be suitable to this GAN. In other words, this vector, we can pass it through this StyleGAN, and this StyleGAN will create an image with face using this vector. In other words, we will not get something weird when we pass this vector, this feature vector, through this StyleGAN. And at the same time, this vector will have some information about our original image, because we used the feature vector that represents our original image to create this new feature vector. And of course, we will train these dense layers to get this suitable feature vector. So we will train these dense layers to make them map this feature vector to the closest latent code in this StyleGAN. So now let's say that we just passed this latent code to our StyleGAN without do any other thing. So we will get something, we will get an image. This image might have some things from our original image, but it will not be very similar to the target image or to the high quality image. Now we will try to make sure that we will get something similar to the target image. How can we do that? Firstly, we will take this feature vector, we will pass it through these dense layers, we will get latent codes. Actually, we will get many codes because here we have many layers. We will put them in sequential way, and we will get from each layer a specific code, and we will pass this code throw specific layer in our StyleGAN. This thing related with StyleGAN. StyleGAN needs latent codes. We will pass the first code to our StyleGAN. We will get this feature map from the StyleGAN, from the pre-trained layer inside this StyleGAN. Now our StyleGAN is trying to draw the image. It will draw this image gradually. So now we have the first feature map from our StyleGAN. What we will do here, we will take this feature map, which might be something similar to this small image, and here we will take it from this place. We will pass it through CSSFT layer, and we will pass the feature map from GAN also through this CSSFT layer. So now what we will do here, we will use channel split SFT. How can we do that? How can we combine this part here with the features from StyleGAN? Firstly, we have this feature map from StyleGAN. We will split this feature map into two parts. Actually, this feature map has many channels. Okay, has many channels. We will take some of them here, and we will take the others here. These channels here, we will not do anything to them, because we need from our StyleGAN to make its magic during building our high quality image. So we need to keep some information from this StyleGAN, and we will not do anything to them. But we also need to guide this StyleGAN, so we need some information from our image, our original image, like this thing here. It will try to predict this image here, this low resolution image. We will try to combine this thing here, which has information about our original image, very low resolution version of our original image. We will try to combine it with the features from StyleGAN. So we will combine it with this part of this feature map with these channels here. Okay, what we will do actually, firstly, we will take this feature map, this thing here, this low resolution, very low resolution version of our original image. We will pass it through many convolutional layers. The output from these convolutional layers will be alpha and beta. We will do something called modulation. Firstly, this alpha here, it is just a vector. This vector, the number of values inside this vector, will be equal to the number of channels here in this feature map. So we will multiply each feature map with a specific scalar value inside this alpha vector. This value will be based on the very low resolution version of our original image. And here we have this vector, and also the number of elements inside this vector will be equal to the number of channels here. We will shift all these channels, the values inside each channel, by the corresponding value in this beta vector. It is like we are trying to combine these two feature maps together to get this thing here. Okay, this thing here will have information about our original image, and at the same time some information from our StyleGAN. And this thing here, we didn't do anything to it. We will combine them together and we will get this thing here. So it is like we are trying to guide our StyleGAN to create something related with our original image, but the StyleGAN will also try to contribute in this image. We will move to another layer in our StyleGAN, and this layer will create this feature map, FGAN feature map, and we will do the same thing to guide this StyleGAN to produce what we want. We will do this thing again and again until the end of this StyleGAN network. So here we will gradually create our high resolutional image, and we will use both the multi-resolutional features from our unit and also the features from our StyleGAN. And finally, that's it. We will get this clear, high quality image. This is the prediction from this StyleGAN. So now, how to train all these things? We said previously that we will not train the layers inside StyleGAN, but we will do something different. We will train these convolutional layers that we use to create alpha and beta. We will train them to create better beta and alpha to make best modulation process. And we will train these dense layers here to create good latent codes, which leads to make StyleGAN works good. So how can we train them? We have many loss functions here. Firstly, let's say that this is the prediction from our StyleGAN. Here we have many discriminator networks. Okay, we have this discriminator global. This network will do the following. It will try to predict if the image that we will pass it through it is fake, to something generated from StyleGAN, or it is the actual image from our dataset. So it will try to distinguish between the real high quality image in our dataset and the generated image. So here we will train the trainable parameters in our network to make this discriminator not able to distinguish between the real and the generated image. And we will train this discriminator to be able to distinguish between the StyleGAN network images and the real images. Now we have also another thing. Here we have these places here in our image, like the eyes and the mouth here. So we have these discriminators. We have these three discriminators, each one related with a specific part. Let's say that firstly we will crop this part here from the image. We will pass it through this discriminator here. This discriminator will try to find if this part generated from this is StyleGAN, so it is fake, or it is from our dataset, it is real. So this discriminator will try to learn how to distinguish between the things that we will get from StyleGAN and the real images. So here the StyleGAN will try to create very good eye to make this discriminator say that this eye is real eye, not fake or generated eye. We will do the same thing for the right eye. We will create this discriminator here, and we will cut this eye from this image. We will pass it through this discriminator. The discriminator will give us if this or it will try to tell us if it is real or fake image. We will train this discriminator to do that, and we will also tune the parameters of this generator to create very good image for this eye, to make the discriminator not able to know if it is fake or it is real. And we will do the same thing for this part here from the image. For this mouth part, we will cut it and we will pass it through this discriminator. The discriminator will try to tell us if this image it is real or not. We will also tune the parameters of the generator to create very good image for this mouth, to make the discriminator not able to know if it is real or fake. Finally, to make sure that we will get the same person in the generated image, the same person that is available in our original image, so we will use face recognition feature extractor. We will use special model, special neural network, that its main task is to recognize the faces in the image, if this face in this image it is similar to this face in this image or not, and something like that. This model trained previously on large data set. Here we will firstly pass our prediction from this StyleGAN. We will get this feature vector, and we will pass also the target high quality image through this face recognition model, and we will get again another feature vector. We will try to reduce the difference between these two feature vectors. By doing this, we will make our GAN network generate the face of the same person, because this feature vector that we took from this face recognizer, it is just focused on the most important thing in the face that we can use to know if this person is person A or person B. Here is the first loss, which is reconstruction loss. Here we have the predicted image and the real high quality image. We will find the difference between them. We will multiply them by this scalar value to specify the importance of this loss or this value here. Plus, here we will do the following. We will use VGG19 network to extract features about our predicted image and the real high quality image, and see the difference between these features. Okay, we will take the features from convolution 1, convolution layer 2, convolution layer 3 until convolution layer 5 from this VGG19. This loss here, it is perceptual loss. We will try to reduce this loss during training by tuning the parameters of our network. Now we have another loss, which is adversarial loss. Here in this loss, we will try to make our GAN network able to defeat the global discriminator. When we reduce this loss, the generator will be able to create very good images. And to control the importance of this loss, we will specify the value of this factor here. We have also facial component loss. Here in this loss, we will pass it through all these parts and we will sum the results. Let's say we have 3 parts. We will pass through all these 3 parts. We will get the loss for each part and we will add them together to get the final loss here. So for each part, we will do the following. Firstly, we will try to reduce this value, this loss here, which means we will try to defeat the discriminator that related with this specific part, or in other words, we will try to generate more realistic part, so to make this discriminator not able to distinguish between it and the real part. And plus we have this loss here. In this loss here, we will take feature maps from many different places in our discriminator for our predicted part, and we will do the same thing for the real part. After that, we will compute a gram matrix for these feature maps, and we will compute a gram matrix for these feature maps. Here, what is a gram matrix? It is just a matrix that will give us the correlation between the features, and by reducing this loss, we will make StyleGAN able to capture texture information. Finally, we have identity preserving loss. Here we said that we will use specific model, face recognition model, as a feature extractor. We will pass our predicted image through this network, and we will pass our real image through this network. We will compute the difference between them, and we will try to reduce this loss function to keep the identity of the image, the real identity of the image. That's it. We will add all these losses and we will try to reduce the final loss. Here we will specify the factors, the importance of each part of the final loss. Thanks for watching.